Welcome to part 3 of Module 201A. In this video, we'll be dealing with objective number 6, which is based on Pythagorean's theorem. Now, Pythagorean's theorem is my favorite mathematical formula in the world. Don't mock me, I do have a favorite math formula. So what Pythagorean theorem is, it's a way for us to solve sides of a right angle triangle. And we looked at this formula a little bit when we looked at our transposing. Whenever we look at a right angle triangle, we have three sides. One is called the base, which is usually represented by the small letter b. The upright, the vertical, is represented by the small letter a. And the hypotenuse is the side that connects those two together, represented by the letter c. Now, Pythagorean's theorem states that the square of the hypotenuse is equal to the sum of the square of the other two sides. Let me show you how this works. If we are going to take a square that is 3 by 3, which would have 9 individual squares on the inside, add it to another square that is 4 by 4, which would have 16 individual squares on the inside, we'd end up with 9 plus 16, which equals 25, which is the same value of a square that is 5 by 5, which has 25 individual squares inside it. That all makes sense mathematically, right? Now, if we were to take the corners of each one of those squares and line them up, what we would find is that between two of those squares, it would form a right angle. Hence the term a right angle triangle. Between those three squares, we now have formed a right angle triangle, one with the side that's 3 units long, another side's 4 units long, and the hypotenuse, the longest side, is 5 units long. And this is why Pythagorean theorem works. Let's look at an example. On the top of the screen, we have our Pythagorean theorem of a squared plus b squared is equal to c squared, and we have a right angle triangle with two known sides. Anytime that we have two known sides, we can use Pythagoras in order to help us solve it. Since side A is 18 and side B is 12, we can put those values into the formula, which means that we have 18 squared plus 12 squared, which is the same thing as 324 plus 144, which is the same thing as 468. 468 is the value of c squared, so in order to solve for c, I need to square root both sides, which means c is equal to 21.633. Double check, make sure that's the biggest value in our triangle, and that is the value of our hypotenuse. If we had another example where we use the same formula, however, now we know what our hypotenuse is and we have to solve for something else, the first thing we have to do is transpose this formula. In order to solve for b, I have to get rid of a squared, so therefore my transpose formula looks like this instead. B squared equals c squared minus a squared. I know when we did the transposition, we had square roots in there and everything else. Sometimes when dealing with Pythagoras, I find it easier to not worry about doing the square roots. Just keep everything as a square and then deal with the square root when you have a number at the end. With our formula now, b squared is equal to c squared minus a squared. We can put in our values and solve. So b squared is equal to 73 squared minus 55 squared, which is the same as 5,329 minus 3,025, which is the same as 2,304. And that means square rooting 2,304 gives us a value of 48. So b equals 48. Now you notice on that last example that everything ended up being a nice even number, and I like those. But what that is called is a Pythagorean triple. A Pythagorean triple is whenever we can have three whole numbers that will form a right angle triangle. Now this is really handy to know in the field, and I learned this when I was a first year apprentice. If you use the numbers 3, 4, and 5, they will form a right angle triangle. So if you were to try to see if a corner of a room was square, for example, from the corner, you measure out 3 feet, and then from the same corner, you measure out in the other direction 4 feet. You should measure 5 feet between those two marks. If they measure exactly 5 feet, that is a square corner. If they don't use that corner because it's not right. So it's handy to know it in the field. This is great math to be able to use very quickly for yourself as well. But understanding Pythagorean theorem for the rest of this semester is going to go a long way to understanding a lot of the math principles that we're going to be talking about in theory. That's the end of part 3. In Blackboard, I do have a worksheet for you that has a number of different triangles to solve for, get used to Pythagoras, get used to transposing the Pythagorean theorem, and then do the knowledge check, and then continue on to part 4.